go to our PO9, which is another fraction objective, but this time dealing with multiplication and division. And like I said off air, it's actually kind of nice because there are fewer rules that you need to remember when multiplying and dividing with fractions than you do with addition and subtraction. But let's start with integers, kind of like we did before, because the other piece with multiplication and division are those signs. Okay, paying attention to those signs. So we have a table here. It's a key point. It can go on a help sheet. Obviously, you will not be able to use a calculator on this section of the test. So having this table on it can be helpful. When you've got a positive number and you multiply or divide that by another positive number, what sign is your result?
Positive.
Positive number. Okay? A little plus there. That's how you kind of first learned multiplication and division. You dealt with the positives only. Okay? If you start with a positive and your second number is negative, so the signs are different, what sign will your product or quotient have? We're on PO9. Binder open? Yeah. Okay. If you multiply a positive and a negative, what sign will your product or quotient have? It'll be a negative. Okay. If the signs are different, it's going to be a negative number. Right? Likewise, if you start with a negative and your second number is a positive, it is going to be a negative. Right? These two are connected. Basically, what you need to look for, if my signs are different, it's going to be a negative. If one's positive and one's negative, it doesn't matter which one comes first. If my signs are different, it's going to be negative. If we start with a negative, there's only one combination left here, right? If we start with a negative and we multiply or divide by another negative, that's going to be a positive, like a double negative in ELA. Okay, a double negative is a positive. Yes, you did. Yeah, yeah. So it's a nice review here. And so you see a connection between these two as well here, right? Oh, there we go. If your signs are the same, whether they're both positive or both negative, doesn't matter. If the signs are the same, the end result is a positive. If your signs are different, doesn't matter which one comes first. If they're different, it's going to be a negative. Okay? So the first one, 8 times negative 3, the basic fact of 8 times 3 is still the same. What is 8 times 3? 24. You know that, right? So then the question is it a positive 24 or is it going to be a negative 24? Negative. Because one of those numbers is negative. Okay? You'll also notice, I'm not using the X to show that we are multiplying. I'm using the dot. What other method do I use here on this page to show that we are multiplying? The dot is one way to show it. What's a second way, Ava?
The one for negative 10 and 6, like the roundy thing?
Parentheses. Yep. If you've got two numbers right next to each other, right, and there's no operation, but one of them is in parentheses, that means you are multiplying here. So this would be negative 10 times 6. You know what 10 times 6 is? 60. Is it going to be negative 60 or positive 60? Negative 60, because one of those numbers is negative. So the actual multiplication doesn't change. You just have to look at what are my signs, and then how does that affect the sign of the final product or quotient, right? Questions? No. Nope. Usually not. Okay. Usually not. I guess, I'll pause the video. Take 20 seconds and run through the rest of these, and then we'll go over answers. And we're back. Here we go. Negative 4 times negative 5. Everyone shout it out.
20.
Positive 20. A negative times a negative is a positive. The 4 times 5 doesn't change. That basic fact is still 20. You just care about the sign. Negative 18 divided by 9.
2.
Negative 2. Negative 27 divided by 3. Negative 9. 12 divided by 2.
6.
Positive 6. 32 divided by 4.
Positive 8.
Negative 20 divided by negative 4. Positive 5. Negative 3 times negative 11.
33.
33. Negative 36 divided by negative 6.
6.
Negative 3 times 7.
Negative 21.
Negative 21. And 48 divided by negative 8.
6.
Negative 6.
Wow.
Okay? Negative 6. Any questions on those? If you were to guess, what do you think, just thinking of like the, from 0 times 0 up to 10 times 10, what is statistically the most difficult multiplication fact for students to remember? What? 1 times 1 is not statistically the most difficult one. That's probably one of the easier ones.
Maybe like 48, or I don't know, like something with the 7s or 8s.
7 times 8, yes. 7 times 8 is statistically the most difficult math fact for students to remember, followed by
Why?
6 times 8. Why? It's kind of an awkward one. Like, you know, usually, like, if you've got 6 times 7, which is up there also, you can kind of go, okay, I know that 7 times 5 is 35, so one more 7 would give me 6 7s or 42. You can kind of work with a 5 there. 8 times 7 is, they're bigger numbers compared to the other ones, 0 through 10. And there's kind of not close to a 5, not close to a 10. 9s, you got that finger trick for all the 9s that you can use. 5s are pretty easy. As that 6s, you know, the top 3 are 7 times 8, 8 times 6, and 6 times 7. So, what's that?
7 times 8 is not hard. Because if you know that 8 times 8 is 64,
Well,
you
it
subtract
might
it
be
by
hard for
I'm
someone, so
saying
you cannot
statistically, right? That means for some it's easy to remember. When I got caught cheating on my 3rd grade multiplication test, on my 8s, 8 times 7 was the one that.
I did that
How'd you
too.
cheat?
Don't worry.
So this was back, so it was 3rd grade, and we had desks where you put your books inside the desk, and it had that like little pencil holder in front, you know what I'm talking about?
Yeah.
You probably, 3rd grade was the last time you had those, maybe 2nd grade, I don't know. Anyway, so I wrote all the math facts down. I was taking my 8s, and I set it on that pencil holder thing, and then when I needed to check something, I just, you know, lean back. Ugh, get a test. So I lean back and take a look. And of course, my teacher is smarter than me. She knew exactly what was going on. So she busted me for it. I had to take the test down in the principal's office, and I put that 8 times 7 was 50, 20. So I did not pass my 8s. This was the multiplication test, you know, the time test. You had to go through your 2s, your 3s, your 4s, yeah. Anyway, traumatizing point in my life. See, that was a pointless story. Who was asking for a pointless story earlier? That was just what I do. I tell pointless stories. All right. Anyway, on to fractions. So, like I said, with fractions there are fewer rules when you multiply and divide them versus adding and subtracting, which is kind of nice. Okay. We do not care about common denominators. Yes. Okay. We don't need them. Right? The rules are just different for multiplication and division than they are with addition and subtraction. So, to multiply, if necessary, convert mixed numbers, and when we convert mixed numbers, we convert them to improper fractions. Maybe you want to add that in there. Okay? So if you're given a mixed number, you want to convert that to an improper fraction. And then you multiply straight across. That's all there is to it. Okay? Negative 10/9 times 3/5. First of all, what sign will our product have? Is it going to be a negative or a positive? Negative, right? We have a negative fraction times a positive one. Our signs are different. According to the chart up top, it's going to be a negative answer. So we go straight across. 10 times 3 is 30. 9 times 5 is 45. And so I've got negative 30 45ths as my answer. Of course, is this the final answer? No, we can simplify it. What can we take out of 30 and 45? What's the biggest number? 5, yes. What's the biggest number you can take out of 30 and 45? Let's do it in one step rather than multiple steps. 15. Okay, if you did use 5, you can simplify a second time once you divide there. But if we start by taking out a 15 from each of them, negative 30 divided by 15, negative 2, 45 divided by 15, negative 3, or 3, and we get negative 2/3 as an answer. Okay? So again, with multiplication, do not care about common denominators. Yip-fitty-doo-dah. Just multiply straight across. If you have to simplify at the end, do it. But there we go. Okay? Let's look at the next one. 2 1/9 times 5/9. We are multiplying here. I see that mixed number. It says convert mixed numbers to improper fractions. What's that going to be as an improper fraction? 2 1/9 as an improper fraction. Madawin.
19 over 9.
Okay. and how'd you get that?
You take the 9 and you multiply
Oh!
it by the 2 and then you add
She's literally telling me. Yes, thank you. We multiplied the denominator by the whole and then add the numerator. So 9 times 2 is 18, plus 1 is 19, so we get 19 ninths times 5 ninths. There's a little like glitch in my board. I'm drawing straight down and it automatically like pushes it over. Look at that.
What'd you do to it?
I don't know. I don't know. Anyway, okay, so we got 19 ninths times 5 ninths. Now that, see, look at that. I'm not doing that. That's not, it's the technology.
Sorry to interrupt. This thing won't recognize the pen. Why is your hood still on? It doesn't recognize the pen. It recognizes just a cursor, so whether it's my finger or this, is there anything I have to do off the top of your head?
Where program are you using?
Smart Note, whatever it's called, Smart Notebook. Don't know.
Don't know.
It's okay.
Just right now.
No
Yeah.
worries.
Is Anne-Marie available?
Oh, yeah. I'm good, thank you.
Okay.
Sorry
Yeah.
to interrupt your class.
No, it's good. Anyway, so we have 19, no, not. I got so obsessed with that. Look at that, it's crazy. Anyway, okay. So we have 19 ninths times 5 ninths. We go straight across. We have common denominators. Great, we have them. Didn't need them. What sign will our product have? Positive or negative?
Positive.
Positive. So 19 times 5 is 95. 9 times 9 is 81. Can we simplify 95 81st? We cannot simplify. Do you have to convert to a mixed number? No. Like I've told you before, improper fractions become the thing now. We don't use mixed numbers a lot anymore. So you can leave your answer in this form, 95 81st. That is totally fine. Totally fine. Okay? Questions on multiplying fractions? Division, you got some options, right? Because we don't actually divide fractions. Okay, we rewrite it as a multiplication question. Remember, in PERMDAS, multiplication and division are connected. They're opposite operations. Okay? Therefore, we can manipulate them to write one as the other. And that's what we're going to do here. Right? Negative 5/5 divided by negative 7/11. First of all, do we need common denominators here?
No.
Again, no. Awesome. What sign will our quotient have? Is it going to be positive or negative? Positive, because we have a negative divided by a negative. So we know it's going to be positive. And so your two options, one of them is use cross products. Okay, and I'm going to erase this over here just so I have some more room to write and explain it here. But what's the whole cross products method? Who can explain the cross products method? Those that like this one, yeah.
You multiply 5 and 11 and 5 and 7.
Yeah, and actually, I'm going to not use this one. I'm going to go down to 9/10 divided by 8/7 just so we can see it a little bit easier here. But yeah, so the cross products method, you're starting with the 9. Actually, I'm going to rewrite this whole thing right over here. 9/10 divided by 8/7. You're starting with the 9 and the 7, and you are multiplying in a cross-like way. Not a cross, but a cross, right? A diagonal pattern. And that's going to give you 63. And you know that 63 goes in the numerator? Because that's where your first number was, that 9. Okay, the 9 was in the numerator, you multiplied by the 7, so you know that that product is going to be in the numerator of your answer. Then you'd multiply 10 times 8. Again, a cross-like pattern, like an X, and 10 times 8 is 80, and you know that goes in the denominator because that's where your first number was, right? Who consistently uses the cross products method to divide fractions? Which, again, we're not really dividing at all here, right? We multiplied, okay?
Wait,
All right? Yeah.
can't you flip the second fraction?
So the other method is flip the second fraction and literally rewrite it as a multiplication operation. Meaning, if we start with 9/10 divided by 8/7, we are going to flip that second fraction and rewrite it to be 9/10 times 7/8. Right? That second fraction has been flipped. It's got to be the second one. Can't be the first one. Got to be the second one. And when you flip it, the operation changes to multiplication. And here's why this works. Is now that we're multiplying straight across, we still end up multiplying 9 by 7. Right? When we flip that second fraction, that 7 is now in the numerator. So to get that 9 times 7, we have to go straight across, which is why we changed the operation to multiplication. We still get 63 as an answer there. Right? Then, multiplying straight across, look, we still multiply 10 by 8. 10 times 8 is still 80. We get the same answer, 63/80. So, really the difference between these two methods here is that if you can visualize the x here, knowing you're going to multiply 9 times 7 and 10 times 8, if you have to see it, you have to flip that second fraction and see what you're multiplying straight across there. It doesn't make a difference. You get the same answer anyway. Okay? Who consistently uses the flipping method? A few more of you. Okay? Both methods work. Let's do another division one, and let's do the 1 1/8 divided by 2 1/4, just because they're improper fractions there. What is 1 1/8 as an improper fraction? 9/8. So we can get that by multiplying 8 by 1, adding the 1, we get 9/8. And what is 2 1/4? 9/4. 4 times 2 is 8, plus 1 equals 9. So we get 9/8 divided by 9/4. Take it from here. Pick a method, either cross products or flipping. Do it. Simplify it if you have to. And then we'll go over the answer shortly. Either cross products or flipping, what's the numerator of your answer? 36 is the numerator. Either, if you use cross products, remember it's the position of that first number where that product goes. So 9 times 4, since 9 is in the numerator of your first fraction, that's where the 36 is going to go. And then multiplying 8 times 9, that 8 is in the denominator of your first fraction, and that's where the 72 is going to go. Okay? If you flipped it, you've got 9/8 times 4/9. And now when you multiply straight across, 9 times 4 is 36, again in the numerator. 8 times 9 is 72, again in the denominator. Probably the biggest mistake that folks make here is they combine the two methods and they flip, but then they use cross products, right? Can't use them both. Okay, got to pick a side. Okay, but once you get 36 over 72, this is not in simplest form. What's the largest number that can go into both 36 and 72? Biggest one. 3, bigger than that. 12, bigger than that.
36.
36 is the biggest one. So we're going to divide by 36, divide by 36 to simplify this, and lo and behold, we get 1 over 2 or 1/2. That's the final answer. So, multiplication and division today. Make sure you simplify. Pay attention to signs. You've got 10 minutes to work on homework. Now your homework is just this first page. Don't worry about the word problems on the second page. We'll tackle that tomorrow. So don't cross them out. We will do them, just not right now. But the rest of the page is yours for homework. Make sure you're writing your answer in simplest form. You can use a calculator to check your answer. The thing about a calculator, though, is that when you do the division and the multiplication, it'll give you your answer at the decimal, which is not super helpful. So if you know how to convert to a fraction, you can use a calculator to check your answer. I can help with that if you want to. But again, you will not have a calculator on this portion of the test. Questions, comments, concerns, complaints, compliments, congratulations, chrisms. All right, folks, that's how you math.
Don't forget to like and subscribe.